Mr. Urs Heckman, how are you?
I'm good, thank
We're
you.
outside the beautiful Funk House.
Yes. Super booth.
Yes, absolutely. I just wanted to have a chat with you really and kind of see how you got to here from wherever it was you started.
Oh, yeah, yeah.
So what was it that got you into, which came first, software, synthesis, hardware or software? How did it work?
Oh, that's really complicated. I think when I was 13 or 14, I was into synthesizers and stuff. I knew I wanted to have something to do with synthesizers, but I also was into computers. And the question was, I had saved up a blob of money, and the idea was I could either have a computer or have a synthesizer. And I went with the computer that had a synthesizer inside, which was the C64. And so I started creating music software on the C64. And well, then after a couple of years, I also had the synthesizer then, and it turned out I wasn't really a capable musician, and I was too lazy to rehearse and all of that. And then later on, I studied industrial design, and in that phase I did some music but didn't do much programming. But then through the internet came back into programming and all of that. And then in 1999, when I finished my studies, I had a project for Sony creating a MIDI sequencer, and somehow this brought it all back together. And I finished that project. It was like an exhibition thing. It was just a one-off thing. And then I decided I wanted to learn more about that. And also I hadn't had enough money to buy all the synths back then that came out with Logic. And then I started creating my own synths. And yeah, and then it all happened. And then suddenly I had something that I sold, and suddenly people wanted to buy that stuff. And
so you started off making things for yourself, essentially?
Yeah, actually. Yeah, I didn't really think it would be something for somebody else. I thought it was too geeky. You know, like when you look at it, the first thing I did was this more feedback machine, which was the most geekiest delay that you could think of, because it was a delay plugin with 89 parameters. I mean, who wanted that, right? And it turned out I didn't want it either. It's like I didn't like it back then, and then I had to do a new version later on, which was easier to handle for me anyway. And yeah, I liked it then. Now I like it.
So was that native coding in kind of VST plugin format? Was that the thing that opened the door for you?
Yeah, basically, yeah. Without VST, it wouldn't have happened. And also, there is a luck moment for me. I think that is when Apple decided to do OS X and audio units, and there were many people who wanted to switch to OS X and audio units, and there were no audio units, right? So, and this was just the time when I started this, and I went right into this, and then I created the first audio unit with a user interface, which is something that you won't find anymore. And then Apple was very grateful, and they put links to my homepage on their homepage. And once you're linked from Apple, you get a lot of people talking to you suddenly. And yeah, and then Imagic back then was still Imagic. They did like a little, I think they did like an interview with me or something on their homepage and all of that. And suddenly I was on par with everybody suddenly, and yeah.
So did you teach yourself the coding side of things?
Yeah.
Okay. So I guess you're working in C+ and all that kind of stuff.
Yeah. I mean, I'm an industrial designer, so right. So I deal with drawings and graphics and all that, and form and function and all of this. But also, the funny thing is that what an industrial designer actually does is he takes a new technology and creates a form for it that people understand. So the content or whatever, or the purpose of industrial design is to make a form for something that integrates something completely new into the context that people are already in. right? And what it ends with for an industrial designer is usually they draw a shape or something and somebody else builds it for them, right? And how I see what I do is exactly the same thing. I create a synthesizer that doesn't exist yet, sometimes with technologies that nobody has ever heard of. And I design a knob for it, I name the knob, and I put it out there. In the end, I have like a two-dimensional image of it. And but unlike an industrial designer, there's nobody coming to build it, but it's code, and I don't need to reproduce it. It just happens by itself. It's a finished product, right? Usually industrial designers end at a stage where, you know, they have to send their drafts off, and it happens somewhere else. And I finish with final product, but it's the same process.
So I guess it's kind of like you're like an auteur. In many ways, you come up with the concept and you execute it yourself.
Yeah.
I mean, that kind of freedom must be very liberating. Or
yeah, it is. But on the other hand, what happened in the past couple of years, the operation became a little bit bigger. So I now have like 12 employees, right?
Yeah.
That comes with responsibility, and you know, you hire all these people so they take work away from you, but they create more work for you as well. So it's like there's a lot of juggling and this and that. There's a little bit less freedom. On the other hand, it's getting to a point where I can concentrate on the things that I like to do more, or that I'm good at. I'm good at certain things, I'm not so good at other things. And for instance, I'm an industrial designer, but I hired a guy who does all the graphics now. I don't do the graphics anymore, which is a really weird thing, right? It's like, it's what I have studied is what I'm not doing anymore in this thing. Of course, he has to present it to me, and I would say, oh, you know, there's something here. This has to go this way, this way. I don't like the color or whatever. So I keep the say, but I'm not executing it anymore.
So you started with effects. When did you first get into the actual sound generation and the modelling side of things?
That was before that, but I never finished it. It was the first thing was a synthesizer actually, which sounded so horrible, and it was really bad. And then I worked on a synth called Zoid, which I never really finished, but that was this thing. I worked from home. I didn't have a good equipment or anything, and this synth got into like an alpha stage. You could play notes and stuff, but it was monophonic, and I wanted to make something polyphonic. But it was a rudimentary synth. And then I went into a store and with a laptop, I think, or was it a USB stick? I think a USB stick was used. Were these around? I don't know. Yeah, something like that. And I went into the store and I wanted to buy better monitors for myself. So, and I said, well, I want to listen to these monitors with this audio unit that I've got on my USB stick here, because this is what I'm doing, and I want to hear what it sounds like. And we put this, and we installed it there. And they hadn't had any audio units yet, and we installed it and we set it up, and then we played some notes, and everybody's like, wow, this sounds great. I was like, oh, okay. So maybe one can do something with it, and this is how it came about, I think. Yeah.
And the other thing, do you get into the component modelling side of things? I mean, how deep do you, when you're creating either models of something else or your own thing, are you thinking in terms of electronics?
Yes. Yeah. This is something that concerns me a lot lately. It's like, how do we get from an electronic circuit to a set of equations, of formulas, and how do we compute these things? This is my actual main topic at the moment that I'm working with or on, and that's the thing. In my opinion, there's a paradigm shift in this plugin or also audio software development, going from the digital academic ideas of so-called direct form filters and all of that towards actually using voltages and currents as the currency of the equations, instead of values and poles and zeros and frequency responses and stuff. It's like when an electronics engineer designs a circuit, he uses these abstract concepts and then knows, okay, I have to use that capacitor there, and I have to use that there. And what we do is we go the other way around. We take the final circuit and say, well, we want to achieve what's done there and approximate it as closely as possible. And we do so by different formulas, which is like this nodal analysis or modified nodal analysis, where for each element, like a capacitor, a resistor, or an op-amp and stuff, we have like a conductance and conductances and current sources, and there are formulas for that, and we use that.
So they are effectively like virtual components that
Yes.
are described in code. Is it like object orientated? Is that the kind of?
You can't really say that. It's actually the opposite of object orientation, because these things are interconnected. You know, if you take something away, the other objects don't behave the same anymore. So you have to always see the circuit as a whole and model it as a whole. So what the circuit emulator does is, or simulator does is, they create a really big matrix where every component has like a couple of values, which is always conductance or current source, and then they connect them to each other, and then they there's a special way in how the matrix is evaluated. Well, it's actually 3 matrices, I think, how they are evaluated. And what we do is, instead of putting all these connections into like the matrix, we just use like direct cables and say, okay, that interacts with that and that and that like that. So we have this equation there, boom, and then it's the same. It's the same math. Just instead of matrices, we use equations.
So is there a trick? I mean, because I know with a lot of software developers, particularly on the kind of cutting edge of DSP programming and that side of it, you have to kind of make your own tools, because there are no, you can compile things, but in terms of the workflow for creating real-time sound generation, there's probably less out there.
There's really, really little out there at the moment. So this is why I've started a blog about it, because there's always people asking me, so how does analog modeling work? What do you actually do? What is it actually that happens there? And it's not that difficult. It's very simple actually, and it's like, you know, SPICE has been developed in the 1970s or 1960s even. So it's not anything magic whatsoever. It's just a different way of thinking, which is why I think it's also a little bit of a paradigm shift to go from the abstract thinking of what is a digital filter like, and it's not designing the properties of the filter, it's designing how the filter actually works, how the electronics interact.
Ah, interesting. So, I mean, the other thing, a big part of what you have to do is obviously you get the blue sky thinking part where you go, this is great, and then you have to optimize, which is, I'd imagine, quite a painful process, because you have to cut out, I guess, a lot of the computing stuff.
Yeah, it's actually the other way around.
Oh, really?
It's, the difficult part is, what uses a lot of CPU. You know, optimization is about CPU mostly, right? What takes a lot of CPU is when you create your code so that it's so open that you can tweak a lot to tweak the characteristics of the circuit or the parts within the circuit, and this is very slow. And once you found those, once you decided I want that characteristic, that characteristic, it's actually quite simple to condense it down to something that works very quickly.
So it's almost like freezing tracks in a DAW.
Yeah, it's kind of like that. Yeah, this is something that we're currently. It's actually an image that I use. Is that an emulation of a synth is usually, it's like a snapshot of that synth at that time, because next day the synth will sound differently.
Yeah.
Right. Or you put it into your sauna, it will sound different. Or you put it into your basement for a year, it sounds different then, right? So if you emulate it like it is right now, it's like a photograph of the sound of that synth at that time. At that moment.
So are you thinking in terms of trying to create aging algorithms into the code, so that things they change over time, or that you can characterize what that process is?
Yes. This is a thing what we're currently doing with like our Repro project. is I've collected a bunch of analog synths, and they have like, for instance, the Curtis chips inside, right? So the Pro One has Curtis chips, and we've got, I think, about 20 of the filter chips, and we've got like 30 of the envelope chips, and we've got like a gazillion of the VCO chips. So what we want to do is we want to swap these and then measure it all again.
And take the. So you're looking for averages, or are you looking for the best sounding ones?
No, we're looking for the bandwidth, and once we know the bandwidth, we can put the bandwidth in knobs, right? So the idea is, if all goes well, I don't know, we haven't done it yet, but if all goes well, then we want to give users like a couple of Pro Ones in there and just one plugin, you know. So because it's always, ever since we released Diva, it's always this problem. Some people come, you know, and they say, my Jupiter 8 sounds so different. And I'm like, yeah, of course it does. Or my Mini Moog sounds so different from yours, and I don't think you hit it well. And I said, well, my Mini Moog, or the one that we had, it actually sounds like that, right? And our Jupiter 8 sounds like that. And then there are those people who do these audio examples where they match a soft synth to a hardware synth, and people then say, I hear the difference, I hear the difference. But the same people would not be able to put in like a sound one day, then change the synth, and next day
or compare two of the same actual synthesizers.
Actually, the same synth sounds. You can't get the same sound on the same synth on the next day. It's not possible, right? And but so we're trying to explore this, just the bandwidth within the differences of synths, the same synth.
And in terms of kind of new forms of synthesis and pushing the boundaries there, I mean, do you feel that do you feel you have a responsibility as an instrument designer to kind of push the boundaries, or is it more exploring particular areas that you were interested in?
No. There's I don't think in terms of responsibility. For me, it's more like what do I see as a challenge, or what triggers me, right? So at the moment, what triggers me are the math behind those filters and the analog modeling stuff. Which is closely related to something that already exists. So it's not. I don't think it's very creative work at the moment, but we have other projects coming up which are completely different. And I have designed in my head some filter algorithms or filter circuits that haven't been put into synths yet, right? Or would be too expensive to put in synths because I can do a lot of parts there. Yeah,
because they're cost-free, I suppose.
Yeah, it's cost-free. It's cost-free. Oh, CPU, of course, but our currency is CPU. But yeah, so I want to explore some algorithms that haven't been built into any vintage or new synth yet, and see how those sound, and yeah, do that kind of stuff. And of course, we also deal with new types of synthesis. I don't have any example right in my head right now, but there's always an idea like, we could do this and that, and this and that. You know, we can create sound this way, that way. Markov series were a big topic like 2 years ago, and it hasn't worked out well, but maybe we go back into that again, and you know, there's stuff.
And one last question: as a software instrument designer, how's your relationship with the hardware control side of things? Because that seems to be that's a puzzle and a riddle that seems to be very difficult to solve.
Yeah, it's utterly difficult. I would love to create my own controllers for my own software, but it's too big for me. It's something as a company, I cannot tackle that. So I have to look at what's there. And as you know, we just worked with Native Instruments. So we have we have Diva as NKS. And this is the beginning of something that we want to explore more and more. Like make our software aware of people who have 8 or 16 knobs there, and make it easy for people to just map it out, and even make it maybe interactive in one way or the other. Native Instruments is currently the closest thing we have, because Native Instruments are the first ones with the Anchor stuff that give us an opportunity to interact with their hardware.
Right.
And I think this is something that will come up a little bit more. And maybe then also the other thing is touch devices, of course. I'm not so into touch devices because I think you need hardware.
Physical relationship.
Yeah. Touch devices are not much different than mice, right? You still operate in free space somehow. But yesterday I checked out the Prophet 6 from Dave Smith, and those are the best knobs I've ever had on a synth. It's like the feel of those knobs is just so amazing, right? And this is what it is for me. I need knobs that have like a resistance, not, and I think somebody will find a solution. I'm happy to help with it, and or to discuss it. But unfortunately, I'm not in the position to build my own. I would love to, but just can't. It's too much.
Thank you very much.
Thank you.